Welcome to this new tutorial of EMWORKS EMAG 2D simulations. A very good feature that is added to the software is this notification for new release. If EMWORKS publish a new version of the software, you will be notified to easily download the newest available version. Now let's get started and learn new tools that help you to simulate different kind of projects. If you want to learn about a specific type of projects, EMWORKS provided a demos folder in the main EMWORKS project folder. Find this demos folder and you have access to different project simulation in 2D or 3D. All the 2D simulations are within this folder and other examples can be seen here. Bus bars, capacitors, clutch and brakes, high voltage insulators, induction heating, magnet array, and many other different projects like transformers, motors can be found in the demos folder. It is a very good starting point to change some parameters and learn more about that application. Let's go into the folder and in parameterization that we talked in the previous tutorial, let's select the PM lifting device. If you open the project, you have access to a full simulation and geometry. Here in this geometry, as we mentioned in the parametric simulation in the previous video, we can go to the variable center and access the variables that are selected for this simulation. For example, distances between parts. If you want to add any new variables, you just need to click on Import Model Parameter and select the parameter that is created in the drawing of the geometry. For example, magnet height, magnet length. Add to the variable list. These two variables are already added to the parameters that we can sweep in the Optimetrics. And we learned how to define variables in the project level and study level, for example, the number of conductors or amplitude of the current. So we opened this permanent magnet lifter and now we have a complete, ready to analyze simulation. This example used magnetostatic simulation and parameterization with different scenarios for magnet length and magnet height. These two variables are swept with different steps, and in the scenarios we have different combinations of these sizes. We just need to click on Run Scenarios and all of these 8 combinations will be solved quickly and we have access to whole results. Let's check the field plots, for example, fringe plot for different sizes. When the field report opened, you can click on parameterization to choose the scenario that you want to plot. For example, I want to plot the magnetic field with the biggest magnet. Both height and width of the magnet is maximized here. And when you select that scenario, the field report will be changed. You can see the size of magnet changed due to the scenario that you selected. If you define force or torque on different parts, for example, this slab that we want to lift, and analyze the simulation again, you have access to tabular results for this force too. Let's have a look on the results center. In the results center, if you click on parameter force, you can see different combinations of the parameter that you swept with the output results. This first tab of the results center spreadsheet is like Excel file. You can use functions to evaluate the results, for example, max of the whole column. This is very a small parameterization, but with higher number of parameters and combinations of them, these functions will help you a lot. For example, let's use the function round the values with only one decimal after the point. And you can work with it just like an Excel sheet. This example was like the previous example that we had, but if you want to explore in different project types, for example, in the circuit, you have single phase transformer, or in electric motors, you will find a brushless DC motor, which is a complete transient simulation with motion, excitation, parameters, permanent magnets, and coils. So, this example will help you a lot to learn more about 2D simulation and its tools and abilities. Before starting any simulation, don't forget to search it in the demos folder to have an initial point for starting.